Deep beneath the surface of Geneva, something truly extraordinary, yet potentially dangerous sits: the Large Hadron Collider, LHC. This huge machine is a marvel of modern science, capable of peering into the tiniest components of the universe, and has already helped scientists make groundbreaking discoveries, like the Higgs boson, often known as the Higgs or the God particle. Boson was a significant find, filling in gaps in our understanding of how the universe operates. But as exciting as this achievement is, there are concerns regarding what might be revealed in the pursuit of knowledge. As physicist Brian Cox once suggested, something hidden has been found at CERN, and it has sparked curiosity and fear. Could we be venturing down a dangerous road, probing realms we don't fully understand? Before we delve into these worries, let's look at what the LHC is and how it works. CERN runs the LHC, a massive 17-mile ring of magnets that forms the largest and most powerful particle accelerator in existence. Its scale and capabilities are awe-inspiring, allowing scientists to recreate the energy conditions similar to those present when the universe began by smashing protons together at incredibly high speeds. The LHC mimics the Big Bang's conditions, making it possible for researchers to probe the fundamental building blocks of the cosmos, with temperatures soaring millions of times hotter than the sun and cooling systems keeping things colder than space. The LHC achieves feats that once seemed impossible. The LHC's intricate setup is a demonstration of human inventiveness. More than 1,200 magnets direct the protons, and another 392 focused magnets direct them to their collision points to accurately strike particles. Think of trying to collide two particles 6 miles apart. It requires an astonishing level of accuracy and technology. The accelerator is buried underground, shielding the world from harmful radiation and maintained at a frigid temperature of 460 degrees. As the particles collide with one another, detectors like ATLAS, CMS, ALICE, and LHCb record the crucial data, collecting insights into the nature of matter and the universe itself. The Higgs boson, for instance, could help us understand how mass is distributed across the universe, giving a glimpse of the entire structure of everything around us. The LHC, on the other hand, is an incredible tool for unraveling the mysteries of the universe, but raises some unsettling questions due to its immense power. As we peer deeper into the unknown, we must ask, are we prepared for the possibilities? Could we be accidentally unlocking forces that we don't fully comprehend? Some have raised the concern that, in our attempts to mimic the Big Bang, we might be opening a Pandora's box of unforeseen consequences. Recent comments by Brian Cox have intensified these worries. He explained that by recreating the extreme conditions of the early universe, the LHC could result in unanticipated, even hazardous results. The collider, after all, doesn't just explore the Higgs boson and other known particles. It also delves into dark matter, which accounts for a large portion of the universe's unseen mass. But dark matter, as the name suggests, remains elusive. Its properties and composition are still a mystery. The LHC could be our best chance at unraveling its secrets. But this could also bring unforeseen risks. The collider's extreme conditions, akin to those that existed at the very birth of the universe, come with dangers that must not be ignored. Scientists have even speculated that the collider could inadvertently create tiny black holes, fueled by the possibility of quantum physics, bending space and time. This concept has attracted the attention of prominent scientists like Stephen Hawking, who warned that high-energy experiments at the LHC could lead to vacuum decay, a catastrophic event that could unravel space and time itself, with consequences potentially as dire as the destruction of Earth. Cosmologist Sir Martin Rees echoed these worries, implying that such instability in the vacuum could have disastrous effects. CERN, of course, insists that any black holes produced by the LHC would be short-lived and harmless. Nonetheless, the idea that we might accidentally create something dangerous enough to be a black hole, even a minuscule one, has made the scientific community more cautious. Despite these warnings, It must be acknowledged that, even though there are risks, they are extremely low. CERN has established safety protocols to mitigate these dangers. However, no amount of preparation can completely eliminate the inherent uncertainty of pushing the boundaries of scientific exploration. As we delve deeper into the fabric of reality, we must weigh the potential risks against the knowledge we hope to gain. The LHC is a tool of immense power, one that speaks as much about the human need for knowledge as it does about scientific progress. It demonstrates our relentless desire to understand the cosmos, but it also highlights the responsibility that comes with such power. Beyond the existential risks, the LHC's effects reach into various realms of knowledge and technology. With over 10,000 scientists, engineers, and technicians working on this colossal project, the collaboration spans the globe. The data generated by the LHC is so vast that it has revolutionized computing, requiring new methods of data storage and analysis. But the implications of the LHC go far beyond particle physics. The research conducted at CERN has far-reaching effects on fields such as medicine, material science, and environmental studies. For example, understanding the Higgs boson better could lead to the development of entirely new materials or technologies. Similarly, the LHC's work on dark matter may one day uncover hidden aspects of the universe, fundamentally changing our understanding of space-time and physics itself. At the same time, the LHC's work with concepts like supersymmetry and extra dimensions could radically reshape our comprehension of the fundamental forces of nature. Supersymmetry, a theory that links two types of particles, bosons and fermions, predicts the existence of superpartners that have yet to be discovered. Should the LHC find evidence of these particles, it could offer a new framework for understanding the universe. The LHC's research also has profound implications for the future of computing, especially in the realm of quantum computing. By revealing how particles interact at a quantum level, the LHC is paving the way for technologies that might, in the future, revolutionize how we process information. Yet, as we stand on the brink of these monumental discoveries, we must also confront the ethical questions that arise. The quest for knowledge is thrilling, but it comes with the responsibility to ensure that this newfound understanding is used wisely. The LHC's potential applications are vast, but so are the risks. From developing advanced weapons to creating technologies we cannot control, the possibilities are both exhilarating and terrifying. This raises an important ethical dilemma. How do we ensure that these findings are used for the benefit of humanity and not to cause harm? Global cooperation and transparency are key to addressing this challenge, ensuring that the knowledge acquired through the LHC is shared and utilized responsibly. The LHC also raises significant concerns about the environmental impact of such powerful technology. With its enormous energy requirements, the LHC places a considerable strain on resources and ecosystems. While CERN has made efforts to reduce its carbon footprint by relying on renewable energy and improving efficiency, the environmental consequences of such large-scale scientific endeavors cannot be ignored. This underscores the need for sustainable practices in science, particularly as we continue to explore the frontiers of knowledge. As the LHC continues to unravel the mysteries of the universe, it serves as a reminder of both the potential dangers and power that come with humanity's drive for knowledge. It's not just about the physics breakthroughs or understanding dark matter. It's about exploring the fundamental components of existence and what happens when we try to manipulate them. With each experiment, the scientists push the limits of our understanding. Yet, we must also be mindful of the profound responsibilities that come with wielding such power. The LHC is a testament to human curiosity, a desire to answer questions that have perplexed us for millennia. But the pursuit of answers in this region of extreme circumstances and unknowns forces us to consider not only the ramifications for science but also the moral and ethical ones. What if, in our quest for knowledge, we uncover things we are not ready to handle? What if the responses to the questions we've posed for centuries come with consequences that we can't predict? One of the most unsettling possibilities is the impact the LHC might have on our understanding of space-time and the concept of vacuum, decay. This has been discussed by some of the leading minds in physics and isn't just an abstract concept. It's a real possibility, albeit a highly unlikely one. But if something went wrong in the vacuum state, a change in the universe could result in a chain reaction that could destabilize everything we know. It's a chilling thought, yet it's one that has to be considered when dealing with such powerful experiments. The LHC could alter the fabric of the universe itself, and while CERN has safeguards in place, it's difficult to anticipate what we might learn and what those discoveries might mean for the very fabric of reality. What makes the situation even more complicated is the global nature of the LHC project. The machine itself is an international endeavor, with scientists, engineers, and technicians hailing from more than 100 nations working together to answer questions that could have made at CERN. Breakthroughs may result in various fields like the study of materials, quantum computing, and drugs, but they also carry the potential for unintended consequences, both in terms of the physical risks associated with the experiments themselves and the implications for morality of how the knowledge is put into practice. How do we ensure that the discoveries made at the LHC are used in ways that benefit humanity as a whole, rather than being exploited for profit, power, or destruction? This brings us to the question of governance and regulation. The LHC is a worldwide endeavor, and the world is at risk due to its potential impact. As a result, it requires global cooperation and accountability that has never been seen before. How can we guarantee that countries with different values, priorities, and concerns work together to manage the benefits and risks of such powerful technology? The LHC is not just a scientific project, it's a global one. Furthermore, its repercussions go far beyond the walls of CERN. Decisions made here could affect the future of our planet, our understanding of reality, and the course of human history as a whole. The importance of transparency, ethical oversight, and global cooperation cannot be overstated. We must engage in open and honest discussions about the potential risks and benefits of the LHC's experiments. The scientific community, the public, and policymakers must cooperate together to ensure that the pursuit of knowledge is balanced with the duty to protect our world and future generations. As we push the boundaries of what is possible, we must also take responsibility for the potential consequences, both the known and the unknown. Then there's the environmental impact. The LHC's immense energy requirements and their significance to the global consumption of resources highlight the need for sustainability in science. The pursuit of knowledge should not come at the expense of our planet's well-being. The scientific community must strive to reduce its environmental footprint and ensure that future generations inherit a world that can sustain their own discoveries and innovations. This balancing act between progress and preservation is a delicate one, but it is essential if we are to move forward responsibly. As we look to the future, the LHC stands as a testament to humanity's unyielding desire to explore, understand, and innovate. But with this incredible tool comes an equally incredible responsibility. The search for the excitement of the unknown is dangerous. It is a journey that requires caution, humility, and foresight. To unlock the secrets of the universe, we must always keep an eye out for the risks and the profound ethical questions that accompany such powerful knowledge. The Large Hadron Collider is, in the end, more than just a scientific instrument. It is a representation of our apprehensions and aspirations, a reminder that although knowledge possesses the power to transform our world, it also carries with it the potential to reshape our very existence in ways that we might not yet fully understand. As we continue to push forward in our search for answers, we must do so with a deep sense of responsibility for making sure the discoveries we make serve to benefit all of humanity, not just the few. Thank you.